we are going to talk about change in state of matter, right? Change in state of matter. So change in state of matter में we have, first we have solid, solid solid takes energy and convert into liquid, right? Temperature at which temperature 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 at which it convert from solid to liquid called melting or fusion point. Fusion point, right? This is solid takes energy and converts into liquid, right? This is called this phenomena is known as fusion. This phenomena is called fusion or melting, right? Temperature at which it occurs is known as melting or fusion point, right? Now liquid converts into gas. Right, liquid converts into gas. For this it takes energy from surrounding. This is converting into gas. So the phenomena is known as vaporization or melting. Sorry, vaporization, or it is called boiling. Temperature at which occur known as boiling point. Is it? This is said to be this energy and this energy, right? Then when it loses energy, gas loses energy, then this phenomenon converts into liquid. It is called liquefaction. Liquefaction or condensation. Condensation. Temperature known as liquefaction. Lique, liquefaction or condensation point. Condensation point, right? And and when this liquid release energy, liquids release energy in surrounding, it is called freezing. Freezing, right? And temperature at which it occur known as freezing point, right? This is we have change in state. This is we called fusion or melting. This is called vaporization. Uh, right. This is we called vaporization or boiling. This is we called liquefaction or condensation, and this is we have freezing. Right. This is the same written in your book. Huh? One more phenomena we have when solid directly convert into gas. इसको बोलते sublimate. Sublimate. This is called sublime. And this is we called sublimation. Sublimation. Solid directly convert into gas, right? Without going intermediate state of liquid, right? These are the different states we have. These are the different states we have, and should I rub this?
Yes.
Hmm?
Yes.
Then for for change in state of matter, either energy absorbed absorbed or evolved, right? For change in state of matter, either energy is absorbed or evolved, right? So latent heat is latent heat. Latent heat is amount of energy amount of energy amount of energy amount of energy required requ- re- required amount of energy required to bring change in state of matter. Latent heat is amount of energy required to bring change in state of matter of whole object whole object whole object without without changing temperature without changing temperature without changing temperature of object. Do you understand? Latent heat is amount of energy required to bring change in state of matter of whole object without changing temperature of the object, right? There is no change in state of there is no change in temperature of whole object, right? So we can say latent heat latent heat L is equal to Q upon M, means joule per kg, right? Or we have a formula Q is equal to ml, right? Now we have specific latent heat. Specific latent heat. Specific latent heat is amount of energy required to bring change in state of unit mass, amount of energy required to bring change in state of unit mass without changing temperature, without changing temperature. You get this? Hmm? The amount of energy, specific latent heat is for unit mass. Specific latent heat is for unit mass, right? And it is for latent heat for whole object. दोनों में amount of energy is required, but no change in temperature, right, of object. Temperature of object remains same. You get this? Okay. So, should I rub? This is latent heat we have. Now, if you take, this is ice. Say 100-gram ice at minus 10 degrees Celsius, right? Then it will convert to water. Ice at 100-gram ice at 0 degrees Celsius, right? So here it is Q is equal to M into C into delta T. This C is specific heat capacity. It is 2.1 joule per gram per degree Celsius for ice, right? Now this ice 0 degree ice converts into
100 degrees Celsius.
water 100 gram at 0 degrees Celsius, right? There is Q is M into L. This L is known as specific latent heat of fusion of ice. This is 336 joule per gram, right? This is latent heat, specific latent heat of fusion of ice, right? specific latent heat of fusion of ice. This 0 degree water converts into 0 degree 0 degree ice convert into 0 degree water. Now this water converts 0 degree water converts to water at 100 degrees Celsius, right? Then we have Q is equal to, this is 100 gram, right? So Q is equal to M into C into delta T. This is C is specific heat capacity of, this was specific heat capacity of ice. Specific heat capacity of water, that is 4.2 joule per gram degree Celsius, right? And now this 100 degree of water convert into steam or gas of 100 degrees Celsius. 100 degrees Celsius. This is also 100 gram, right? This here is again Q is equal to ml. Here L is specific specific latent heat of specific latent heat of vaporization vaporization or boiling of water. Boiling of water, right? And that is 2000, that is equal to, here L is equal to 2260 joule per gram, right? So this is, we have specific heat capacity of fusion of ice. This is specific latent heat of fusion of ice. This is specific latent heat of fusion of vaporization or boiling of water. And this is specific heat capacity of ice. This is specific heat capacity of water, right? This is, we have change in state of matter. When there is change in state, when there is change in state then latent heat. Specific latent heat, right? Otherwise, Otherwise, we have specific heat capacity. See, right? And as I told you, latent heat unit is joule per gram or joule per kilogram. You get this? I told you earlier. Hmm?
Yes.
This much is sufficient. This is you have in your book. What else is there? Initially, whatever amount of energy we are giving, मतलब latent heat is that whatever amount of energy you are offering, that whole energy is utilized in changing state of matter, right? Temperature does not rise. Temperature and when the whole temperature get change in when there is change in state of matter of object, then temperature of the object start rising, right? Right. This is the concept we have, and there are certain phenomena are also written there, na, in your book. Here itself, if we put some impurities, then what happens? When impurities are put some impurities, when we put some impurities, then freezing point,
Effects of impurities on point
boiling point, what happens? Boiling point increases, or है ना?
by addition of impurities.
Boiling point increases, huh? और फिर
Laterally,
huh? Right, then you have what do you have?
explanation of latent heat of melting on the basis of kinetic model.
It is that when you give heat to an object, that heat increases the kinetic energy of the molecules of matter, right? And when they get sufficient amount of energy to escape, right, yeah, to overcome the intermolecular force of attraction among them, they leave the surface of the object, and this leaving is when they get sufficient amount of energy, then they start leaving the then they start uh, leaving the surface of object, and there is change in state of matter. Kinetic energy, matlab when you heat, kinetic energy increases. When kinetic energy increases, then this intermolecular force of attraction weak goes it goes it becomes weak, right? And then they start leaving the surface. When it occurs, whole phenomena, matlab when it occurs in whole object, which occurs at its boiling point, or uh, you know melting point, right? Then it is called uh, this causes change in state. What is written in your book?
According to the kinetic model, the molecules in solid vibrate about their mean positions.
Yes.
The total energy of a molecule is the sum of its kinetic energy
And
due to its motion, which depends on the temperature, and its potential energy, which depends on the force of attraction between the molecules and the separation between them. When a solid changes into a liquid without any change in temperature, the average kinetic energy of the molecule does not change, but the separation between the molecules on an average increases. Some energy is required for increasing the separation against the attractive forces between the molecules. For the increase in the potential energy of molecules, since the increase in volume is negligible, so no heat energy is used in volume expansion. Thus, the heat energy supplied during the melting is utilized only in increasing the potential energy of the molecules is called the latent heat of melting.
latent heat of melting. So in kinetic theory of atom, what happens? Kinetic, sorry.